Okay, in today's lecture, we are going to discuss the linear motion under gravity, or we can say freely falling bodies. Okay, it's a very easy topic. Here, to solve the numericals of the linear motion under gravity, we are going to use the same equation that we have discussed in a straight line motion. The three equations that we have discussed in a straight line motion, same equations we are going to use to solve the numericals of the free falling bodies. Okay, these equations are V is going to be U plus AT, S is equal to UT plus half AT square, and the third equation is V square is equal to U square plus 2AS. And these are the three equations that we have discussed in straight line motion. Motion along the straight line. Okay, here what is a U? U is the initial velocity. What is a V? V is a final velocity. And what is S? S is a displacement. And T is the time. And A is acceleration. Okay, these three equations I am going to use to solve the questions of the linear motion under gravity. Okay, I'm going to make bit change in these equations. Okay, as we are going to discuss the motion under gravity, it means the acceleration that we are going to take is going to be g. Okay, in this case, in case of acceleration, I'm going to use g. To solve the numericals of the this topic, I'm going to use one sign convention. While solving the numericals, you need to take care of the signs of the values that you are taking. Okay, if anything is in an upward direction, I'm going to take positive. If anything is working downward, I'm going to take this as a negative. This is a sign convention I'm going to use. Always remember, if the velocity is in an upward direction, I'm going to take this as a positive. If the displacement is like this, from here to here I have moved, I will take positive. Okay, whatever value I am taking in an upward direction, I will take them as a positive, and whatever it is which is working downward, I am going to take it as a negative. This is a sign convention that I am going to use. This is very important to solve the numericals of the linear motion under the gravity. This is very important to consider while solving the numericals of the gravity. Okay, as we know, the gravity always works downward. Gravity always works downward. So whenever we are going to discuss the questions of the linear motion under gravity, the acceleration will be what? Acceleration will be minus of g, na? Why? Because gravity works downward, and as per our sign convention, we are taking downward as a negative and upside as a positive. Okay, in these cases, the acceleration will be minus g, minus of g. Okay, and I'm going to use these three equations. Instead of a, I'm going to put a minus g, and whatever values I'm taking in an upward direction, I'm going to take them as a positive, and whatever I'm going to take in a downward direction, I'm going to take them negative. Okay, that much theory is there in this type of question. Now let's see question. We are going to practice some question, and we will see how to use these formulas. Okay, now we will see how to solve the numerical of this topic. For that, I'm going to consider very basic question first. Read this question. A ball is projected vertically upwards with initial speed u, then find maximum height, time to reach the maximum height, speed at the half the maximum height. Okay, let's see how to solve this type of question. Here I am having a flat surface. Let us consider this is point A. From point A, I have vertically thrown a ball. I have vertically thrown a ball in an upward direction. Okay, ball is going to travel some distance. After that, it's going to stop for an instance. Now, just for an instance, is going to stop and it will start falling back. It will start falling back. It will hit the ground. Okay. When you're going to throw a ball vertically upward, it will travel some distance in upward direction. It will travel some distance in a upward direction, and then when it's going to reach a maximum height, for just a bit of second, it's going to stop at a maximum height. Then it will start falling back to the ground. Okay. Now, okay, let us consider a maximum height the ball have reached is a h. Or you can say h max. This is a maximum height which the ball have reached. Okay, and we have thrown a ball with a initial velocity of u. Now, as per the question, the initial velocity with which we have thrown a ball is u. Okay, let's see how to solve this type of numerical. The first, I'm going to calculate the maximum height. Maximum height the ball have reached. Okay, what is the initial velocity? Initial velocity, as per the question, the initial velocity is u. Okay, in order to calculate the maximum height, I am not going to consider a complete journey. The ball started a journey from here. It have traveled up to point B, then it came back to point C. But in order to calculate a maximum height, I am going to take half of the journey. I am going to reach B only. Okay. In order to calculate a maximum height, I am considering this as a one journey. A to B. A to B. I am discussing only about A to B. Okay. If initial velocity is u, what is the final velocity? When the ball have reached the point B, what is the velocity? What is the final velocity? This is 0, na? As I told, the ball will travel some distance in upward, and just for an instant it's going to stop, then it will start falling back. It means the final velocity for the point B is 0. Okay. Now use the third equation of a straight line motion. We know v square is going to be u square plus 2as. Okay. But here, what is the a? What is the acceleration? Here, the only acceleration present is a gravity, and we know gravity always works downward. Gravity always works downward. As I told, the sign convention that I'm going to take, it will like this. If I'm taking any value upward, it's going to be positive. Any value I'm going to take downward is going to be negative. It means a is going to be minus of g. Okay. What is the initial velocity? Initial velocity is u, na? Okay. What is the final velocity? Final velocity is 0. Okay. Just tell me what is s. What is the final displacement in this case? From A to B, the maximum, the displacement is h max, na? Positive or minus? It's going to be positive. Why positive? Because I am taking h like this. I am taking a upward direction from A to B. From A to B, it's a upward. That's why I am taking h as a positive. Okay, now put the values, these values in this equation. What you will get? 0 is equal to u square minus of 2g h max. What you will get? You will get h max is equal to u square upon 2g. This is your formula for the maximum height of a ball when it is thrown at a initial velocity of u. Okay, now we will see how to calculate the time to reach the maximum height. Time to reach maximum height. Time to reach max height. Okay, time to reach the maximum height. How to calculate? Use the first equation. Okay, use the first equation of the straight line motion. Motion in a straight line. Motion along a straight line. Okay, this is a v is going to be u plus at. What is the a over here? A is a minus of g. Initial velocity is 0. U minus of g, and this is a time t. This is a time t when the ball have reached the point B. Okay, then time will be given by how much? U upon g. This is a time when the ball is at point B. This is a time when the ball is at point B, because the initial velocity at A is u, the final velocity at point B is 0. The same values I have put it over here, and I got t is equal to u divided by g. Okay, now we will see the third part of this question. the third part of this question. See the third part, speed at half the maximum height. Okay, let's see. Speed at half the maximum height. Okay, speed at half the max height. Okay, the initial velocity is going to be u, same na, initial velocity is u, initial velocity when we have thrown a ball is u. Initial velocity is u. Suppose when the ball is going to be at a point, let this is a point, some point D. When the ball is at point D, the velocity is not zero na, because it is still moving in a upward direction. It means suppose the final velocity, it means the velocity at D. Velocity at D. Or I can say final velocity for my case. Final velocity is somewhat u. Just I am taking final velocity u. I need to calculate this now, speed at a half the maximum height. Okay, and what is the s? What is displacement? Displacement is h max divided by 2 na, half of the maximum height. Now put this value. I am going to use the third equation again. Okay, v square is going to be u square plus 2as. What is the a? We know in the gravity always the a is going to be minus of g, because gravity works downward. Put the values. V square is going to be u square minus of 2gs. What is the s? S is a h max divided by 2. Okay, now put the values. V square is going to be u square minus 2 and 2 got cancelled. You can say g h max. What is the h max? H max is u square upon 2g. G and g got cancelled. It's going to be u square minus u square by 2. U square minus u square by 2. Or you can say v square is going to be u square by 2, which is equal to u upon root 2. This is your final answer. Velocity at point D is going to be u divided by root 2. This is your final answer. Okay, now we will discuss the another question of the topic, linear motion under the gravity. Okay, now let's see the next question. Okay, it states a ball is dropped from an unknown height. Okay, it takes 0.2 seconds to cover the last h meters of its fall. H is given as 6. Find the height from which it was dropped. Okay, let's see how to solve it. Here we are having a ball at some unknown height from the ground and it is dropped. Drop means initially it was at rest. Then what is the initial velocity of the ball? When it is at rest, it means it is going to start from 0 na. Initial velocity is 0. Okay, the ball is dropped like this. The ball is dropped like this. Okay, but as per the question, the last 6 meters, last capital H meters, H is given as 6 now. The last 6 meters it covers in 0.2 seconds. It takes 0.2 seconds to cover the last 6 meters of its journey. Okay, let's see how to solve this. Here we are having a point A. This is a point B and this is a point C where the ball is going to hit the ground. And I am considering this distance. From A to B, this distance is small h. I am considering this distance as a small h. Okay, let us consider first the AB section of this journey. I am considering the AB section of this journey. What is the initial velocity? Initial velocity u is 0. And what is the final velocity? Final velocity means the velocity at point B. Na? Velocity at point B. Velocity at point B. Because B is the final point as per for this calculation. AB section. Na? AB sections means A is the initial point, B is the final point. The velocity at point B. I am considering this is a V. Okay. What is the S for this journey? It means how far, what is the displacement, you can say, what is the displacement between A to B? The displacement I'm going to take as a minus of h, no? Because h, it is traveling from A to B. And as I told, I'm going to take upward as a positive and downward as a negative. It means the ball is traveling from A to B now, but have traveled as distance downward. That's why I'm taking minus of h. Okay, now I'm going to use the second equation of a straight line motion, which is, sorry, I'm going to use the third equation. I'm using third equation. V square is going to be u square plus 2as. 2as. What is the a? What is the acceleration? It is under the gravity, na? It means minus of g. Why minus g? Because g always works downward. It means, what is the v? V square is going to be u square. U is a 0, na? Initial velocity is 0. Plus 2. What is the a? A is a minus of g. What is the s? S is a minus of h. Is it clear why I have taken a minus of h? Because the ball is traveling from A to B downwards. That's why I have taken minus h. V square is going to be 2gh. Here I can write V is equal to under root of 2g small h. This is the value of V. Okay. Now I'm going to take BC section of the journey. BC part of the journey. Okay. It means B is the initial point. This is the initial point. And what is the C? C is the final point of the journey. Final point. Okay. What is the velocity as the initial point? What is the velocity at B? Velocity at B is going to be the initial velocity. Now it means the initial velocity for this case is how much? This one. Initial velocity for this case is going to be 2gh. Now, is it clear? Why? Because I am discussing about the BC section. BC sections means B is the initial point and C is the last point. That's why I am taking the velocity at B is the initial velocity. Okay. What is the S? What is the distance? Distance is minus of 6. What is the time taken to cover this distance? 0.2. 0.2. Okay. Now use the second equation of a straight line motion. We know S is going to be ut plus half of at square. Okay, what is the acceleration? Acceleration is going to be minus of g, na? So write like s is a minus 6. What is the initial velocity? Initial velocity is u 2gh, you can write, na? Multiplied by t is 0.2 minus 1 upon 2g, na? Instead of a, I have put it a minus g. T square. T is going to be 0.2. I am discussing what the BC section. Na? Time taken to travel the 6 distance is 0.2. Na? That's why I have put it a values like this. Okay. Now from here, if you will calculate, you will get h is equal to 42.05 meters. 42.05 meter. Then what is the actual height of a ball from ground? It's going to be h plus capital H. No? H plus capital H. Capital H is a 6. Na? It means 42.05 plus 6 is a actual distance of a ball from the ground. This is going to be 48.05 meters. This is the actual distance of the ball from the ground. Okay, let's see the next question. Okay, now look at the next question. Read the question first. If a ball is thrown upward with 5 meters per second from a tower of height 10 meters, find. Okay. Before discussing about this question, I need to mention a few things. Like, okay, if we are releasing a ball, from some height, releasing a ball, or when we are dropping a ball from some height, when the ball is dropped or we are dropping a ball from some height, always remember the initial velocity is going to be 0. Because when we are dropping a thing or releasing a thing, it means the initially that ball or that body was in rest. It means the initial velocity is going to be 0. Okay. When we are throwing a ball, it means we are providing some initial velocity to that body. we are providing some initial velocity to that body. It means when we are throwing a ball, the ball will have some initial velocity, and when we are releasing the ball or dropping the ball, the initial velocity is going to be 0. Okay, and always remember, in the cases that we are discussing, the linear motion under the gravity or free fall under the gravity, we are not going to throw the object at some angle. We are either throwing upward or we are dropping downward. Either we are throwing upward or we are dropping downward. We are releasing downward. We are not going to throw at an angle. If we are throwing a ball or object at an angle, then this question belongs to the projectile motion that we will discuss later. The projectile motion. Okay, here either we are throwing a ball or releasing a ball. If you are releasing a ball, it means the initial velocity is 0. If you are throwing a ball, it means here we are having some initial velocity, and we are always going to drop a ball or we are going to throw upward a ball. We are not going to throw a ball at some angle. Always remember these things. Okay. Here, as per the question, now come to the question. Here we are having one tower like this. Here we are having one tower like this. Let us consider we are having one tower whose height is given as 10 meter. 10 meter is given as the height of the tower. And from the tower, I am throwing a ball upward. Okay. For some time, it's going to be cover distance like this, and for the time instance, after reaching the maximum height, for a time instance is going to stop and it will fall back to the ground. It's going to come back to the ground. What is the initial velocity? I have thrown a ball with an initial velocity of 5 meter per second. Let us consider this is point A, this is point B, the maximum height point, and the ball is hitting a ground at point C. Okay, now let's see how to solve this. The first case, time taken by ball to reach the maximum height. Time taken by ball to reach the maximum height. It means it is discussing about the AB section, A to B. It is discussing about A to B. Time taken by the ball to reach from A to B. It means initial point is A and the final point is B. What is the initial velocity in this case? Initial velocity means velocity at point A, which is 5 meter per second. What is the final velocity? Final velocity means velocity at point B. It is going to be 0, na? Okay, let's t time taken by the ball to reach the point B. T is a time, and we know the acceleration in this case is how much? Acceleration is minus of g, na? Because gravity always works downward. Now put the values and use the first equation. First equation we know v is going to be u plus at. V is 0, u is 5, a is minus of g, t. What is the t? T is going to be 5 divided by g. G is going to be 10. T is going to be 0.5 seconds. It means the ball will take 0.5 seconds to travel a journey between A to B. Okay. Now, maximum height gained by the ball. It's very easy. Maximum height gained by the ball. It means it is again discussing about the AB section. Na? We are discussing about the A to B. A to B. Okay. Maximum height gained by the ball. We will use third equation. V square is equal to u square plus 2as. Okay. This distance. I am discussing the distance between A to B. What is the final velocity? 0. Initial velocity 5 square minus 2gs. S is the distance between A to B I am considering. Now put the values. 25 is going to be 2 multiplied by 10 multiplied by s. From here you will get s is going to be 25 divided by 20, which will equal to 1.5 meters. This is a distance between A to B. Okay, then what is the maximum height of a ball from the ground? It's going to be 1.5 plus 10. Now, if it is asking what is the maximum height of ball from the ground, it is going to be 1.5 plus 10. But it is asking the maximum height gained by the ball. Maximum height gained word is over here. The maximum height gained by the ball, this is the maximum height gained by the ball. This is 1.5 meter. Okay, now we will discuss the next part. Okay, now read the next part. Time taken by the ball to reach the ground. Okay, let's see how to solve a time taken by the ball to reach the ground. Let's see in a diagram. What time have been taken by the ball to reach a ground? Means we are discussing about a journey from A to C. Now we are discussing about journey from A to C. The ball initial point is A and the final point is C. What is the initial velocity? Initial velocity is 5 meters per second. Okay, what is the time? It is asking the time taken by the ball to cover the journey between A to C. Okay, can you see what is the displacement between A to C? What is the displacement? Not distance. Now S is a displacement. What is the displacement between A to C? The displacement is the minimum distance between 2 points. Now it means displacement between A to C is 10 meters. You will see displacement between A to C is 10 meters. Okay, it's minus 10 or plus 10. I will write minus 10 now. Why? Because A to C I am traveling downward. A to C I am traveling downward. It means S is over as minus 10 in this case. S is minus 10 in this case, and we know the acceleration is going to be minus of g. Now use the second equation of the straight line motion. We know S is going to be ut plus half of at square. What is the S in this case? S is minus 10. Initial velocity is 5. Time I need to calculate minus of 1 upon 2. G is going to be 10 multiplied by t square. Time I need to calculate. Okay, now solve this. You will get the answer. Minus of 10 is equal to 5 of t. Is going to minus of 5t square. It means we will get t square. I am taking this minus of 5t minus of 10. Divide with 5. T square minus of t minus of 2 is going to be 0. Now solve this. You will get the answer. Okay, solve this. T square minus of 2t plus t. I am factorizing. Okay, take t as a common. T minus 2 plus 1 I am taking a common. T minus 2 is going to be 0. Here t minus 2 and t plus 1 is going to be 0. Okay, then you will get how much? T is going to be 2 and t is going to be minus 1. The time is not going to be minus, and t is equal to 2 is your answer. T is going to be 2 is your answer. Is it okay? T is equal to 2 is your answer. Now look at the next part of this question. Velocity of a ball while hitting the ground. Okay, it's very easy. Again, it is discussing about the A to C, or you can also solve using the section B to C. Okay, I am using the same section A to C. The fourth part I am discussing. What is the initial velocity at A? 5 meters per second. Okay, final velocity it is asking. Final velocity it is asking. And what is the time taken by the ball to reach A to C? T is going to be 2 seconds. Just we have calculated. Time taken by the ball to reach from A to C is 2 seconds. Okay, then use the first equation. V is going to be U plus AT. V we are calculating. U is 5 meters per second. Instead of A, I will put minus of G, and time is 2. It means velocity is going to be 5 minus 10 multiplied by 2. It is going to be 5 minus 20. Is it okay? Velocity is going to be minus of 15. What do you mean by minus 15? What do you mean by minus 15? It's a downward. Now it is hitting a ground like this. It is hitting a ground like this. It means that the minus sign represent here downward. It is hitting a ground in a downward direction. That's why I'm getting a minus sign over here. Okay, this is a very basic question, and all the concept I have discussed in this question. Okay, now look at the next question. Okay, now look at this question. The first ball A is dropped. When it reaches the near ball B, the ball B is dropped at that instant. Find the difference in time of hitting the ground. Okay, let's see how to solve this. Here we are having a ball A and here we are having a ball B. Ball A is at a height of 20 meter from the ground and ball B is at a height of 10 meter from the ground. Okay, first we have dropped a ball A. As it reaches near the ball B, then ball B is also dropped. Ball B is also dropped, and it is asking what is the difference in the time when both the ball is going to hit the ground. What is the difference in the time of hitting the ground? Okay, first let us consider ball A. Okay, I am going to discuss about the ball A. Let us consider this position. This position I am naming as P, and this position I am naming as Q, and this position I am naming as R. Okay, first let's see for the P and Q distance. P and Q. P is the initial point, Q is the final point. What is the initial velocity? I am dropping the ball. It means the initial velocity is going to be 0 now. Okay, what is the distance traveled by the ball between PQ? This is minus of 10. Why? The distance is 10 and it is downward. It means minus of 10. Okay, the time I am going to calculate. What is the acceleration? Acceleration is always going to be minus of g, which is equal to minus of 10. Okay, now solve. Minus of, you can write the second equation of a straight line motion. S is going to be ut plus half of at square. What is, okay, S, which is a minus 10. Okay, ut 0 because initial velocity is 0 minus 1 upon 2, gravity is 10 t square. This is going to be 5 times, minus and minus going to be cancelled. 10 divided 5 by 5, 2. It means t square is going to be 2. You can say t is going to be root 2. Time taken by the ball A to reach the point Q is root 2. Okay. Now consider a journey PR. Consider a journey PR for the ball A. I am discussing about the ball A. Okay. What is the initial velocity? 0. Okay. What is the distance traveled? Minus of 20. Okay. Time I am going to calculate. Time taken by the ball to reach the point PQ. Time taken by the ball to reach the point R from the point P. What is acceleration? Acceleration is going to minus of g. Okay, now use the equation directly. Minus 20 will be equal to 0. Initial velocity is 0 minus 1 upon 2. G is 10 t square. This is going to be 5. Minus and minus is going to be cancelled. This is going to be 4 times. T square is going to be 4. T is going to be 2. Let's see. For ball A, P to R is 2 seconds and P to Q is how much? Root 2 seconds. Then what is the time taken by ball to reach Q to R? Q to R. This total time is 2 seconds. This time is root 2 seconds. Then what is this time? This time. This is going to be 2 minus root 2 now. Okay, now note down this. This is going to be 2 minus root 2. Okay, this is for the ball A. Now we will discuss about the ball B. Ball B. Okay, when the ball B is dropped, what is the initial velocity? 0. Okay, distance travel minus of 10. It is traveling downward. Okay, what is traveling from R Q to R, na Q to R. Okay, time I am going to calculate. What is the acceleration? Acceleration is going to be minus of g. Acceleration is going to be minus of g, which is equal to minus of 10. Okay, minus of 10 will be equal to 0 minus half. What is g? 10 t square. T is going to be how much? Root 2. Ball B takes root 2 times to travel a journey between Q to R, and ball A takes this much time to travel the journey between Q to R. Now you can easily find the time difference now. The time difference between the time taken by ball to hit the ground. Delta T you can say. root 2 minus, this is the time taken by ball B, minus 2 root 2. 2 minus 2 root 2. Is it okay? It's going to be root 2 minus 2 plus root 2, which is going to be 2 root 2 minus 2 seconds. This is a time difference between that. I just have calculated the difference between the time of A to B. Okay, delta t, difference between these two terms, this term and this term. I have calculated difference between these two terms. It's going to be 2 root 2. Okay, this is about the free falling object under the gravity. Okay, from the next lecture we will discuss the projectile motion.